Let me just run through the list of questions real quick, and we'll go ahead and get started with the material for today. One question was, can you start more than one debug session at a time? And no, it wouldn't let me. Right as soon as I started one debug session, it grayed out the option to debug. So apparently one is all you can do at a time. Another question was in the old debugger, the 4GL debugger, there was a command called let that you could use to change a variable value, and the equivalent now is set. So you can use a command like set variable var test equal 10, right? So you can do it with our debugger. It's just the set command instead of the let command. Let's see. Another question. When you delete a line of code that has a breakpoint, does it delete the breakpoint? And I assumed yes it would, right? But actually I was wrong. It does not delete the breakpoint. It moves it down a line, which is kind of interesting. So if there's already a breakpoint at that next line, it just stays on the empty line where you delete the line of code until you run a debug session, and then it gets deleted. So it actually deletes the breakpoint at that point. Otherwise, it just stays there, right, or it just moves to the next line. So I guess you need to be careful if you delete a line of code and you had a breakpoint on that line of code and you don't want it anymore. I guess you have to take that extra step and actually delete it. Otherwise, it just hangs around at the next line.
I'm sorry, is that next line up or next line down?
Next line down. Like if it was on line 4 and you deleted line 4, it moves down to line 5.
Oh, okay, so the new line 4. That makes sense.
Right. It would be the new line 4. All right, let's see. And another question we had is kind of an ongoing question, but I tested it out pretty thoroughly yesterday and again this morning, was the watch points. Remember yesterday we were talking about watch points, and we decided it was kind of a shame that you couldn't keep your watch points at the end of a debug session like you can a breakpoint. But the macro did work for me. I don't know if it would work for every situation, but I went in and created what they call a macro, just basically a list of commands for the debugger that gets stored in a file. And then the next time you go into your debug session, you can actually call up that command file and run it again, and it will go in and recreate that list of debugger commands. And that worked as well for watch points and conditional watch points as well. So maybe that would be an alternative to not saving those watch points like we were talking about yesterday. What do you think of that? Does that sound like a workaround at least?
Yes, it does. Can you show us how to create macros sometime today?
Yes, I can. If you'll remind me at the end, I actually saved the little command file. You know, there's not much in it, but it does have a watch point, I think a breakpoint, and a conditional watch point in it, so I can show you how to recreate that with that little command file. You just might have to remind me, because sometimes after an hour or two I kind of forget.
That'd be perfect.
Okay. All right, so that is doable. I don't know if it answers every problem, but it does work. Let's see. And another question, do you have to have a Studio Server installed on the production system to do remote debugging from like a development machine that has Studio installed there? And the answer is yes. I did run that by Laurent, and he said yes, that's true. And I think that's it. Can anybody think of any questions that I didn't get to or didn't write down yesterday before we move on?
How about the one where you have 2 different modules with the same variable?
Oh, yes, thank you. We spent a good deal of time on that actually yesterday. I guess if there is a short answer, the short answer is it does not differentiate between whether that variable that's currently in scope is global or local or modular. And as it moves through the program, it updates the variable value in user variables. The original question was, hey, if you've got a variable that you've copied to user variables, does it just change when the variable that you copied is in scope? And the answer is no. It updates that user variable value when that variable with the same name changes in the function or as a global or even as a local. Did I say that already? Module. That sounded a little confusing. Did you follow that okay?
No.
No idea.
All right, let me show you. Hang on a second. Whoops, wrong button. Hang on.
One of the things I personally was curious about is if you have two functions with the same variable name and you set it to, I forget the correct word, but if you set it to conditionally break based on the change of a variable's value, then the question becomes, if the variable has the same name and it's used in two different places, will that trigger the dynamic breakpoint?
I haven't tested it, but I'm going to guess yes, because of the behavior that you'll see here. Delane actually created a little program for us. Let me just show it to you here. All right, I've already got the little breakpoints set up, so it should be ready to roll here. So here we've got a variable called varTest that he has set here as a global variable. Let me set my watch points here. Okay, I'm going to have to roll forward one step here before I can do the watch point. Oh, sorry, I'm thinking of something different. Here we go. All right, so I'm going to take it down here from global variables. Right-click it and copy it to user variables. Okay, so there it is in user variables. All right. So right now it's global. And I'm going to go ahead and just step through one step. And here it's getting set to 76. So I'm going to move on so we can see it. Oh, I've already moved into the second module. All right, let me start over, Kent, real quick, because that messed up our sample here. Sorry about that. One more try. All right, let's try it again. All right, go into Data tab. There's varTest down at the bottom. I'm going to copy it to user variables, so there it is. I'm going to step to the next here. Can't see it, can you? Let me drag this over. All right. One more. So now it's set to 76 up here in the user variables. And you can see down here under global variables that it's also 76. So the global variable's in scope right now. I'm going to hit next again, and it's calling another function. So we'll pop over there. Now we're in the other function where we have varTest again, using the same variable name. I'm going to pop down here where we're setting it to 99. Roll forward one line, and you can see that there it is in local variables down here in the Data tab. Can you see that okay? Is it big enough?
Yeah.
Okay, and then you can also see that the user variable up at the top has also been updated. So it's not differentiating between whether that original variable that we copied up there was a global variable or local or modular. So let's go on down. I think there's one more. Okay, so now we're back in the main after calling gtest, and now the value has been set to 4 again. So our global is back in scope. So it's updated the user variable as well. So in other words, wherever that variable is, that when it becomes, when it gets in scope, that updates the user variable as well. So it doesn't have any memory of where it came from.
That makes sense, but it's based on the scoping.
It's just based on the scope. It doesn't care where it originally came from. Okay.
Yeah, that makes sense.
Okay. So I guess the rule of thumb, would be try not to ever use the same the same name, but I know you guys said yesterday that you had inherited some legacy code, maybe, where you were having that problem, where you had some.
Yeah, that's all we have is legacy code. There's tons of it. What happens is you have a program that you write or that you acquired to modify, and you're accessing libraries that might access the same variable name.
I see.
So if you have a special name like var test, maybe that won't apply. But if you have like a counter like I or CNT or something more common,
right,
then libraries might use it as well, and it would sort of. I couldn't see how it would be possible for the environment to keep track of different versions of the same variable.
And you're right.
It's within the realm of technology, but I don't see it doing something like that. But anyhow.
Well, actually, from the support guys talked about that as well and said, that it's not really a bug. They don't consider it a bug, of course, because it's it is the same name. But what they said you could do if you really needed to be able to tell during a debugging session, where that variable was in scope and what the value of it was when it was in scope in a, like as a global or a function. You could actually use the up command, the up and down command, or the frame command from the command line options, and it will actually show when you print out the value of the variables, it'll show you the correct value for that frame. So you could track it that way. So using the up command or the frame command. All right. Anything else before we move on this morning? All righty. Let me get rid of that. Bring up our slides this morning. I did reduce some of the slides yesterday afternoon, yesterday evening, and I'm hoping very much that you'll be able to see those screenshots better today. If not, we can always pop in and out of Studio. It's a little bit time consuming is the only thing, so it may take us a little bit longer. All right, let me see here where we were. I think right here. Okay. Get rid of that. Little housekeeping here. Bear with me a second. Okay. All right. So yesterday we stopped at the end of Module 2, which I think the last thing we really talked about there was tracing application logic with the debugger. So today we're starting with Module 3, which gets into some of those commands we kind of skimmed over yesterday. Watchpoints, conditional watchpoints, conditional breakpoints, those types of things that are a little bit more advanced type features for the debugger. So we're going to look at those today. All right, so we have two topics in Chapter 3, analyzing logic errors. We're not going to go step by step through analyzing logic errors. That was what the lab was designed to do. So if you have your lab or if you've downloaded your lab, even though you may not be able to actually perform the lab on a real environment, it might even help to just kind of walk through it mentally just to see the commands and what we use those commands for in the lab. And then topic 2 is only a few pages long. It's analyzing fatal errors. Really what it's about is the debugger is probably best suited for analyzing logic errors. When you have a fatal error, essentially the program terminates abnormally, of course, because of the fatal error, and at that point you can't really use the debugger to go, like we were talking earlier, you can't go backwards. So you can't go in and do like resume with the debugger or do a next or continue. You would have to start over from the beginning again. So really the debugger is best suited for logic errors like we're talking about here in this chapter.
Lisa?
Yes?
When you get a fatal error in the debugger, does it save the state? In other words, can you still look at global and local variables, or do they all go away?
They all go away. Yeah. So So that's the thing. It just kind of, at that point, I think what you would end up doing would be more towards things like turning on logs, right? Turning on logging and having the errors maybe get dumped to the log file at that point, and that might be a better debugging tool for a fatal error like that.
Maybe set the breakpoint to the line before it failed and rerun it.
Right. Yes, you kind of backtrack that way till you figure out exactly where it's failing. So you could go at it that way too. All right, debugging logic errors. So all the things we looked at yesterday still apply when you're analyzing errors. They were just more or less the building blocks for what we're learning to do with analyzing actual errors. So breakpoints are still necessary for debugging. Those commands we learned, like the next, continue, step in, step out, all of those are used with analyzing errors as well. And all those views, of course. You'll need the views to go in and monitor variables, change the values of variables, a lot of the things we're learning today. So now we'll focus on additional debugger features like breakpoints, which we talked about yesterday, but we'll focus on conditional breakpoints, watchpoints and conditional watchpoints. Some new commands. We've already talked a lot about them just because of some of the questions yesterday, but the interrupt command can be handy. The up and down commands to be able to track what caused you to be in a certain place in the program, maybe track where you're at when the actual error occurs. So it's a lot easier to find an error with some of these commands. You don't spend a lot of time with display statements and that type of thing trying to track them down. Same thing with the backtrace view. I think the up command and the backtrace view are both really helpful for tracking down how you got to a certain place in the program. How did it get here where I'm having this error? And we talked about being able to change variable values. So we're actually going to see that today. We've talked about it 2 or 3 times, but this time we'll actually see it in today's session. Now here's one of my changed slides. I just took the slide and kind of tore it in half and blew up the part that we're focusing on. Can you see it better today?
I can. Yes.
Good. Okay, good. Well, I did that with all of these screenshots that we were having such a problem with yesterday, so I'm really glad that it helped. Okay, good. All right, so here is conditional breakpoints. So, of course, you can't see the entire studio interface because we ripped off the part that we're interested in here, but you can tell where we're at. We're down here at the bottom of the studio interface. Grab my highlighter. We're in the breakpoints view. And then down here in breakpoints, we've seen this before yesterday where you could see all of your breakpoints. You've got this integrated toolbar that you can use to disable them, delete them, enable them, and so on. But now we're talking about this column, the condition column, where you can go in and create a conditional breakpoint. And there's an example of a condition. So we use variables, just like we talked about that we'll see in a minute with watchpoints. But the big difference between, of course, a breakpoint and a watchpoint we talked about yesterday is a breakpoint is going to, at a specific line of code, where you've set that breakpoint, even though it is conditional breakpoint. It's only going to stop at that line if the condition is true, right? If the Boolean is true. A watchpoint, on the other hand, if it's conditional even, can stop anywhere in the source code anytime that expression is true. So that's really the difference. You're doing the same thing basically by setting a condition that has to be true to stop the processing. But the big difference is it going to stop on this same line of code every time if it's true, or can it stop anywhere in the program, anywhere in the application? So that's a conditional breakpoint. So it's only going to stop on this specific line of code, like this one down here at the bottom, line 98, if our expression, if pState equal 2, happens to be true, that iteration of the breakpoint. Now we're talking about watchpoints. So a watchpoint, that's the same idea. We want to stop program execution so we can take a closer look at the code, maybe check the variable values, that type of thing. But this time we want to do it when a variable value changes. And we don't care what line it is. It can be anywhere in the application. So to set a watch point, you actually have to already be in the debug session. So that's one other difference between a watch point and a breakpoint, is that breakpoints can be set outside of debug sessions or inside debug sessions, but watch points can only be set inside a debug session. It already has to be running. So here's the steps up here on the screen. You have to set a breakpoint so that the program will stop to enable you to set monitor variables and set a watch point. Start your debugging, click the Data tab, and then find your variable and then choose the Add to Watch option from the context menu. Grab my marker here. It's trying to get away from me. There we go. All right. So Add to Watch. So in this case, it looks like they're wanting to watch action number there. So anytime the value of action number changes, wherever it happens to be in the application, it's going to stop on that line of code. And notice it says there is a Watchpoints View. I don't think we've had a look at the Watchpoints View, but you can see it down here at the bottom of the screen. And we'll take a look at it here in just a sec. So here is the Watchpoints View. It's kind of hard to say. Watchpoints View. You've got an integrated toolbar in the Watchpoints View just like you do the Breakpoints View. So you can use that to enable or disable your watch points or delete your watch points if you like. And notice that just like in the Breakpoints View, you've got a condition column here. So just like you can with breakpoints, you can click on the condition column like you can see here that they've done. And then you can just type in your condition right here if you want to. Or you can right-click, highlight the line here, the whole thing, right-click, and then you can say Edit Condition. So that's what they've done here, or what I did here to get this screenshot. And then you've added a condition. If action no equals 15, then it will stop at that line of code where it's actually set the number to 15. The interrupt command, I think we've talked a bit about the interrupt command. The lab did a really nice job of explaining why it might be really helpful. Let's say that you're running an application that does have an error in it, some sort of logic error that you're trying to locate quickly. The interrupt command can help you do that very quickly by just starting the debug session. You don't really need to put in, say, more than maybe just an initial breakpoint for the debug session. And then you can, let's say, wait till it gets to the part of the application where you know there's a problem. And if it's sitting at an interactive dialog statement, you can just hit the interrupt command and it'll pop it out and bring it back to debugger control and show you the source right there in the code editor view. So that's sometimes a quick way to find an error, specifically, particularly if you're at an interactive dialog or at a natural place to be able to suspend the program. So the interrupt can be pretty handy because it shows you the source code that's being executed at the moment that you hit that interrupt. So if you know about where the problem is, you can hit the interrupt right there and be very close to it in the source code. So it can save you a lot of display statements or a lot of stepping and nexting with the debugger. You can also use it to interrupt endless loops. So that would be kind of an obvious use for the interrupt command. If you can tell that an application's in an endless loop, you could certainly interrupt it to get the control back to the debugger. Now here's this up command and down command that we were just talking about just a few minutes ago before we started the session. So here we've got an application. We've got the commands up from the debugger. I kind of blew this up so you could see it better. There's the up command and the down command. Now the up command actually, let me see if I get this right. It works its way towards the outermost stack, right? The outermost function call, one up at a time. So if I go in here and I hit up multiple times, then I'm working my way out back to, let's say, the main program block, right, that first function call. So that's up. It works its way towards the outer stack. If I do down, it does the opposite, right? It comes back in, back to the current stack, function stack. So essentially you're using that to track where you've been, right? The different function calls that have been made to get you to the point you're at in the application. Pretty useful too for setting breakpoints, right? Let's say I'm debugging and I use the interrupt, for example, because I know I'm close to a problem area in the code. So I hit the interrupt button. I can also then go in and use this up command and go to my outer stack, the first outer stack. And if I want to, then I can go ahead and right there in the source code create a breakpoint, right, so that I can slow down and stop now that I'm getting close to my error. Does that make sense? Everybody following that okay?
So up and down are just view only, is that right? It doesn't actually change the execution of the debugger.
Correct, correct. It's just looking to see what has been executed, and you can do several ups in a row, right, to see the function calls and the calls, the line of code and so on. And as you work your way up, when I click up, it actually pulls the source code back into the viewing area, so I can see the source code for that stack that I'm looking at. So it goes backwards, I guess you could say, in the source code. So then I can go in here and set breakpoints if I want to, even though I'm past that function now. So that makes it handy for the next debug run, right? You've got your breakpoints now at some of those functions that led up to the point where your problem is.
And you have to use up before you can use down because
right, right.
You're already at the innermost
stack.
Yeah.
Yes, exactly. Yes, you have to use up first and then you can use down. All right.
Is there any way to do a full stack trace in just one command instead of having to use up repeatedly?
You know, you may be interested in some of, like some of the things we're going to look at in Chapter 4. For some reason, I'm just going as blank as I can be. I want to say maybe the sequence diagram might get you what you're looking for there.
Okay.
So when we take a look at that, remind me, and we'll see if that's maybe what you're looking for.
Okay.
All right. Now here's the backtrace view, and that may be all you're really looking for. Take a look here at this screenshot. The backtrace view more or less does that, right? Here it starts down at the bottom with the main, and then works its way from bottom to top with your function calls. So would that maybe be what you're looking for?
Yeah, that's it.
Awesome. Okay, the backtrace view then. So that will get you there. That was a nice segue to the backtrace view. So here finally is where you go to change variable values. You can go to the Data tab and find your variable that you want to change. Usually, of course, you're in the middle of a debugging session here where you're actually maybe you've got a clue as to what the problem is, and you're thinking, boy, the problem here is that this is somehow getting set to an incorrect value, and let's see what happens if I change it to this. So a lot of times this is more or less experimenting with possible solutions or trying to diagnose what's going wrong by actually editing these variables during the session. And then, of course, when you finish editing the value, you can go right in and resume the session, and it'll pick back up with this changed value. So you can see how the behavior changes for the application. See if you were right? Okay, that looks like that would be the right solution. So now I just need to figure out why it got changed to the wrong value back here. So that's a good way to test and experiment changes in behavior during the actual debug session. All right, that was the end of that topic. It was fairly quick. Anybody have any questions about the backtrace view or the up or down commands or conditional breakpoints or watch points? Anything?
One question about watch points. If I want to at a watch point on a variable, a local variable inside a function that I'm not presently in? Is there a way to specify that without actually going to the debugger to get into that function?
Now, I was thinking you might add that to, I haven't tried it, and I don't believe it will let you add it as a watch point unless it's in scope,
Okay.
right? So I think that's going to be your problem. I think it has to be in scope before you can do it.
Lisa?
Oh, hi, Delane. Do you know the answer to that?
You're correct in your statement. I would suggest that you could set a breakpoint by module name and line number, and then get a watch point once you hit that breakpoint, if that makes it easier. If you know the line number in the module that you're debugging, even though it's not displayed, I believe you can, on the command line portion, you can type BR for break and then module name dot 4GL colon line number.
Okay. Thank you. Did you guys get that?
Yes.
Okay. All right.
That's what I've always done.
Okay.
At the moment, that's the only way that I would know that would make it simpler for you to set a breakpoint if you know where you want to put a breakpoint and you can't currently do it because the module's not in scope.
Right, yeah.
All right. Thank you. All right. Well, let's go ahead and take a look at topic 2. As I mentioned, it's a very short topic. It's talking about...
Can I ask you a question, Lisa?
Sure.
Are you going to talk about the backtrace function later?
I was trying to think. I don't think so. Do you want to add some? Go ahead.
I just wanted to add, if you're interested in a backtrace for logging in an error log, there is a function available in BDL that you can log backtrace in your error logs. We can discuss that later if you'd like. I'll send that info to Lisa.
Oh, we do have that. Sorry, Delane.
Okay, great.
Yeah, we do have it. I think it's in Chapter 4.
Okay.
All righty, thanks.
Let's talk about it then.
Okay, we'll do it then. All right, so fatal runtime errors, saying when fatal errors are encountered outside the debugger, of course the program bombs, terminates, you get an error number, a message on the screen about the fatal error. You get a little more information when you're inside the debugger running a debugger session. So if you notice, it's identical bullets down to the last one. And in the last one, you get one more line of information, the line number and the statement in the source where the error occurred. So you do get a bit more information if you're inside the debugger running a debug session when you have a fatal error. But like we talked about a few minutes ago before we started the session, you can go back then and you can use your debugger features to trace the program flow with your breakpoints and watch points up to the point of failure. But once the program terminates from that failure, from that fatal error, you can't do a next or a continue or step up or step down because it does terminate and you lose your information, if that makes sense. So all of your information about your debug session disappears. So again, that might be where you're more interested in looking at log files or just going back in and setting appropriate breakpoints and watch points so that you can get right to the point of failure so you can debug the fatal error. But there's no way to go backwards after a program has failed. Okay, so that was all of Module 3. I'm not sure what time it is, but I was aware yesterday that you went a couple of hours without a break. So let me see, it's 11:30. Well, that's not bad. All right, I'm assuming everybody is still okay. So we'll go a bit further here with the miscellaneous tools and considerations, and I think you'll be fine without a break today. If you do need a break, feel free to flag me down anytime, and I'll be glad to give you a 10-minute break or a 15-minute break, whatever you need. So Module 4, miscellaneous tools and considerations. Just, I would say a lot of this is just odds and ends that some does relate directly back to the debugger and some do not. They are just all useful topics or useful tools for debugging applications. So we thought that might be a good way to end the course with some of these other tools and commands.
Lisa, real quick, can I ask you a question that I forgot to ask earlier about stepping through the code before we
Sure.
get into this?
Okay.
If we have an include statement in some of our, which we do have in some of our code, which brings in an external file, stepping through the code, will it step into those external files when you're running it through the debugger?
Now, Delane, make sure I get this right. It will step through them if you have added them to your project. And then, of course, you would either need to have, is that correct? I believe that is correct. But they have to be.
In fact, didn't you in Module 1 give an example of that where you loaded the lib column?
Yes, in the lab, I did, right. Yes. And so I believe that is correct. The only way that I can see that it steps into the code for an external function is to add it to the project. If it's in the project, it'll pull it up and open it.
Well, just a little caveat about this, though. It only step through 4GL code, I believe, if you're importing C or Java.
Does the extension have to be 4GL, even if it's like a module, but it just has a different extension?
Well, anytime that you import 4GL stuff with the import statement, it has to be contained in an import FGL.
Well, this isn't an import. I'm talking about an include, like a compiler directed include, which takes it and puts it in line at compile time.
Oh, okay. The include, I believe the include gets read in at compile time, so it should be available. I'll mute and check that out and let you know.
Oh, that would be great. Thank you. All right. So here's our miscellaneous topics. We've got the code analyzer. We've got something called a profiler that you can use to locate bottlenecks, problem areas in the program possibly where it's spending a lot of time. Just a topic I called miscellaneous because I had several things there and none of them were really related, so I just stuck them all together in a miscellaneous topic. And then finally, topic 4 is another short topic where we're talking about isolating problems with a web application where you've done perhaps a lot of customization. So 3 or 4 slides there about how to try to isolate where the problem is. So the first topic is the code analyzer, which is really 2 tools that are used for reverse engineering an application. So it actually 2 different tools. You've got a couple of diagrams that can be created. The first one is what they call a dependency diagram. And the purpose of the dependency diagram is to show you the relationship between, let's say, your source files primarily, right? Your source code files, your modules. Then you've got something called a sequence diagram, and the purpose of the sequence diagram is to show you the relationships between the functions. So 2 different tools, one at one level with the actual source files, the modules, and another a little deeper level with the actual functions and how they relate, who calls who, that type of thing. So here's the dependency diagram, and we can take a look at these 2 in Studio if we have a few minutes. I'll be glad to kind of go into that so you can see it moving around and actually working. But this is what a dependency diagram looks like. Now over here on the left-hand side, notice that you open dependency diagrams from Project Manager. So right there in Project Manager, you can right-click on an application node or a project node, the whole project node, and there's an option to open the dependency diagram. So that's what's happened here. Somebody has clicked on the actual project node in this case, right? The whole project for our Office Store project. And if you click on one of these nodes or right-click on a node, you'll get a context menu that gives you the option, for example, to expand or collapse the node so you can see all the subcomponents if a node has subcomponents. There's an option to locate in the project. If you want to see the component, like I could click over here on orders, right-click on orders and say locate in project, and it would pop me right over here to Project Manager and highlight the orders application node, for example. I can open a node in a new tab up here at the top of this view where the dependency diagrams are displayed. So I'll see an additional tab up there separate from this one. I can open a new tab. Right-click on another node, for example, like the Accounts node, and say Open a new tab, and it'll pop up in a different tab. There's a filter view. For example, if you have a pretty complex project, there might be an awful lot of things on the screen, a lot of nodes, a lot of arrows and lines. It gets confusing. And what you can do is actually filter the view so that you don't have to look at the entire project. You can just focus in on certain aspects of the project. And if you use that along with this hide selected item down here at the very bottom of the list, you can clean up the diagram, so to speak, so that you can focus in on just the parts you're interested in. So you can use the filter view and hide selected item to get rid of all the extraneous nodes so that you can really see what's happening with the part of the application you're interested in. So that's a dependency diagram. Oh, now, to get here, let me back up just a second. They right-clicked on this Entities node. You can see that the Orders and Accounts application nodes both have dependencies on entities. So you can right-click on that Entities nodes and click the Expand option. And then you get something that looks like this, right? So this is, you can see right here in the corner, this was the Entities node that we saw in the previous diagram, and it's been expanded. And it does look a little crazy, right? There's a lot of nodes, a lot of arrows. Everything looks like it's pointing to everything else. So again, you can collapse the diagram if you want to and start over. You can use the filter view to get rid of some of this. If you're not interested in the entire overview, you can filter it. Here's what that filter view looks like, right? So if you click on that Show the Filter View, it gives you a list of all the different components in the project, in this case, since it was a project level diagram. And I can go through here and select the ones I don't want to see. So we've selected orders here, and then notice when the diagram gets refreshed, the Orders node that was right down here at the bottom no longer appears. Now it's still not completely clean. All the information about orders is not gone from the diagram. So this is where you might also use the hide option that we talked about a minute ago to go in and actually maybe delete some of these others or hide some of these other orders nodes from the diagram. And that way you could focus in, for example, just on accounts if you wanted to. So you can manipulate these diagrams quite a bit as you go along. Now when you're looking at the dependency diagram, over here on the right-hand side, there's the structure view, and of course this time it's the dependency diagram structure view, so that you can also kind of manipulate the diagram or navigate the diagram by clicking on the nodes here in this tree view on the right-hand side. So that's another way to kind of feel your way around the diagram. If I click on something over here in the structure view, it will actually highlight it over in the diagram so that I can see what's related to what real easily. And that's handy, of course, for a really large, complex project. That would be really useful. This one's not that large, so you're like, I'm not sure if I'd ever use that. But if you had a really large, complicated project, you can see where that would be handy, to be able to focus in on certain parts of the diagram without having to look for it too hard. So there's the project structure view here on the right. And also, of course, you can click on nodes and these links between nodes, like this arrow here. And you can click on those, and those will actually show you the function calls between two components. So that's what's happened here. Someone has actually clicked on the link between this account form UI node and the account form UI data node, and it shows you all the different functions that are in play there. So then you can analyze all the functions and which functions call which functions and so on. So it's a good way to kind of trace your way around a program. That's another way, I guess, that you could go in and trace the logic for an application. Now from this function view down here at the bottom, that kind of makes a good segue for what they call sequence diagrams. That's the second tool for the code analyzer, was the sequence diagrams. So you can right-click one of those functions in the structure view over here on the right-hand side. You could right-click one over here in the function view, and there's an open sequence diagram option that you get. So here's what the sequence diagram looks like. It's got this stick figure over here on the left, and that shows you user interaction, right, where the user enters the program is how I would interpret the stick figure. And you can follow or trace the program logic, the function calls and whatnot for the application by following this program flow here. Anywhere where you see a plus symbol like that on a node, that's an indication that there's additional subcalls. So it tries to keep the sequence diagram fairly simple, but you can click on these plus signs and open that, expand that node, and of course it may bring up 1,000 more subcalls. It's just depends on how complex the application is. But so here we can see how the user enters the program, what functions that function calls. This one here, for example, this libdbapp-util-set-open node, it returns back to this account form UI open form. Then we have another function call. So you can literally trace all the function calls from beginning to end if you use this sequence diagram. And you can keep opening these subcall nodes until you see everything. They can get fairly complex. Now here's the profiler. We mentioned a minute ago in the topics that the profiler is a tool that you can use to find where your program is spending the most time or spending all of its time. So the idea, of course, is to be able to look for bottlenecks with the profiler. It's included with the runtime system, and one of the things that the profiler does is tell you all the functions that are called and how much time is spent in each function and subroutine. So you use this option, Execute with Profiler. So it is a separate tool. It's not part of the debugger, right? A lot of the things in this chapter are actually separate tools from the debugger. You execute with Profiler, and then you just run the application just like you normally would. Pick some options that are common options for users to use. Work your way all through the application, and when you terminate, it actually dumps out all of this profiler statistical information to standard out. So in our case, of course, it'll be in the out point view. It has two sections. This is talking about the output for the profiler. There's two sections. There's one they call the flat profile section, and it's just strictly a list of functions called. Has a table here that you can look at. Tells you how many times this particular function was called. And a lot of these are just basic runtime things here. Now here's main down here at the bottom, so that one would apply to us. The count, the number of calls for the function, the percentage of time spent in the function, and notice the total percent line includes any time that was spent in subroutines that were called from the function that you're focusing on. The percent child is focusing on the percent of time spent in functions that were called from the function that you're looking at. And the percent self is the percentage of time spent in just this function, and it excludes the time that was spent in subroutines that this function called. And then finally, of course, the last column is the actual name of the function. So that's the flat profile section. There's two sections. Here's the second section, and for this one I just decided it was really hard to see, so I just more or less copied and pasted it up here so I could blow it up really well so you could see it better. So here's the call graph section. Here is the function we're focusing on here, this one with the little asterisks, the 3 asterisks. So it's actually a function called FC. And it's telling us here, here's the index. Every function is, I guess we could say, numbered, right? It has its own index when in the output. So this is function number 4 that we're focusing on. It was called twice. The first, or one of those function calls was from the main, and one of those function calls was from a function called FB. So we can actually track which functions called function FC. And then this directional arrow, right directional arrow, means that FC called function FA, and it actually called that function 7 out of the 8 times that that function was called during the program execution. Goodness, any questions about that? That seemed complicated. Okay, so that's the call graph. And then here's this miscellaneous topic, topic 3, a lot of just kind of odds and ends that we thought might be helpful. There is such a thing as a breakpoint instruction. Now this, of course, is directly related to the debugger. So it's only used when you're in a debug session. Otherwise, this breakpoint instruction in the code that they've actually put in the code here is just ignored. So that's nice. If you think you might be going back and re-looking at an application, maybe it's had a history of being problematical or something, you can actually put some breakpoint instructions in there, and that way when you are in a debug session, they're already there and ready to go.
Does it actually break on that line or the next line of executable code?
It will break on that line. I actually have one of these. I could test it. Let me test it just to be sure, but I'm pretty sure it breaks on line 22 in that example.
Okay.
But I'll verify. Just write down a little note here real quick so I'll remember to do it.
Lisa, is there a way, once you put a breakpoint in line, when you're in the debugger, is there a way to disable it?
It is just, oh, I see what you're saying. Like in the debug session, can you disable it? That's what you mean. I honestly don't know. I'm thinking you'd have to perhaps comment it. That's a good question. I'll check that too.
Because say it's inside a loop, you know, and do it for so many
Right.
times, and I want to move on.
I suspect you'd have to comment it out, but I don't know that, so I'll check just to find out. Can you disable the breakpoint from the instruction? Good question. All right. Sorry, did somebody say my name?
Yes, it's Delane.
Hey, Delane.
That particular breakpoint is a special. It's a special feature. I need to read the doc, but to disable a breakpoint, the only ones that you can disable are the ones that are listed on the breakpoints tab.
Okay.
If you go to your breakpoints tab, there's checkboxes to be able to disable them, or you can disable them all at the same time. Let me just real quick pull up the breakpoint docs.
This is nice. We might get the answer to it before we move on. That's a whole lot easier.
Okay, so this is kind of treated as a hard breakpoint. It is only relevant when you're running in debug mode. So if you're not running in debug mode, say you're executing your application normally, that instruction is ignored. However, if you're running in debug mode, it's considered a hard breakpoint, so it will stop at it every time. The only way to get around that in debug mode is for that instruction to be commented out.
Commented out. Okay. Okay.
Yeah, you had alluded to yesterday that you can modify code while you're debugging it and have it execute. So could I comment that line out while I'm in the debugger? And
if I alluded to that, I was mistaken. You can't, it won't let you edit code while you're in a debug session, or at least I haven't been able to. Will it, Delane?
You can edit, you actually can edit code while you're in a debug session, but it's not going to be active for that session until the code's recompiled.
Okay.
In other words, it has to be saved in the file, and then the debug session stopped and restarted.
Okay, but
early yesterday when we were just getting started, kind of having technical issues, so just kind of flew by.
right, right, yeah. Because I've just kind of forgotten that I was in the debugger. Sometimes, you'll be looking at errors, and you'll kind of forget you're in there sometimes because the source is displayed, and it doesn't accept the changes, like it would if you were just in code editor, for example. So
it was just my pipe dream.
Well, that's a good one. I like that too. All right. Now this is just, I think, just to show you that this is here. This is the SQL CA record that I'm sure you are familiar with, that you can query, with your applications to check SQL status info. It's been around forever, I guess. But it's part of the Data tab, and I didn't know if you had noticed it or not. But one of the things you can do is actually check the SQL CA record right here in the Data tab. So that's all this is. It's nothing, I think, new for you except the fact that it's part of the debugger to make it easy to see. Here's the STARTLOG built-in function that you can use to turn on error logging. And of course, if there's not already an error log file there with the name you specify here, it will go ahead and create the error log for you. So there's how you can debug and put all your errors out to a log file so that you can pore over them later. Do some of these look familiar to you?
Yes.
I thought probably they did. And here's the getStackTrace that I think Delane was referring to earlier. Is this it, Delane? He might be deep in the throes of testing that. But this is the getStackTrace method that I believe Delane was referring to earlier, that you can use to get a full list of function calls. So this is kind of the equivalent of the backtrace view, right, in the debugger. So this is how you can do it programmatically. So this would be useful on a production site, right? When you can't use the debugger easily in a production site, you could use this instead and have it dump it to an error log file. So that's another way to get to the same information. Here's some environment variables for debugging. There's an FGL GUI debug environment variable that you can use that shows you all the protocol exchange in standard error. There's one for SQL debug that can be very verbose, that displays just about everything, it looks like, that has to do with SQL when you're processing. There's a WS debug environment variable that you can use to track the exchange of data between web services applications. And then there's a special environment variable just for report writer to turn on debug logging for Report Writer. Are you familiar with those?
No, we're not.
Okay. I'll show you. Of course, you can set those. Depends on your environment, of course, but you can set those just like you would any other environment variable. If you're working in Studio, there's an actual debug environment set where you can set those, and I'll show you those if you're interested when we finish the slides here in a minute or two, if you'd like to see where you can actually turn those on.
Yes.
Okay. Just remind me if I forget. Sometimes I do. I'll try to remember one thing and forget something else. Now this is another setting that you can use that has to do with debugging, but this time you're actually preventing debugging with this. It's not an environment variable, it's an FTL profile entry. So we kind of switched gears from environment variables to FTL profile entries. So this actually will prevent somebody trying to start an application or to put an application that's already running into debug mode on a production system. So it ignores sig traps or control breaks on Windows to avoid putting an application in debug mode. So that might be something you'd want to do in a production environment to prevent somebody from putting a production system in debug mode when they're not supposed to. So just add an entry to the FTL profile, FTL run.ignore debugger event equals true. And then finally, the last topic, it's only a few pages long. It's talking about isolating problems in web applications. If you've customized your web applications, which I believe you have, those custom layers, CSS, JavaScript, those we've already discussed are outside the scope of the debugger and really outside the scope of debugging at a Genero level. So one of the problems sometimes can be figuring out exactly where the problem is with a web application that's been customized. So one of the things you can do to try to isolate where the problem is, whether it's a problem at the Genero level or a program logic error or whether it's a customization problem, is to try running it in different environments to see if the problem goes away or if the problem still hangs around. So a suggestion is, even though it's a web application, you might actually try first running it when you have a problem and you suspect that it might be a customization problem. You might try running it with the GDC, the Genero desktop client first, and see if the problem resolves itself or if the problem is still there. And then if the problem resolves itself, right, there isn't a problem when you run it in the GDC, that does tell you something, right? It tells you that it's probably not a language problem, you know, like a logic error or an application problem. It tells you it's probably something to do with the fact that it's a web application. And then from that point, you might try running it with one of our built-in web themes that we have right there in Studio. You could do it in Studio or outside of Studio, and try it with just our default templates, right, without your customization, and just see if the error is still there or if the error has resolved itself. And then just compare the behavior with our default templates with your customized templates, and that would be a way of being able to tell whether it was something to do with the Genero level or something to do with the actual customization layers. So right here in Studio, if you use Studio, you could just use the desktop client and run your web application from the desktop client. And if the problem that you're having is still there, it probably is something that you could maybe use the debugger for or use our technical support folks to help with, right? It looks like it might be related to something Genero, logic error, programming error, something along those lines. If it resolves itself, right, and there's not a problem with GDC, that kind of puts you at the next level, which is, okay, it looks like it's something to do with the fact that it's a web-based client. So you could try it with one of our built-in themes. You've probably played with these before. Down here at the bottom of Studio, you've got these different web themes that you can try. The default one there is just Ajax. And try running the application in Studio with one of our standard themes and see if the problem is still there or if the problem goes away. And again, if the problem goes away or it's not evident with our just default templates, our simple templates, then it's a good chance that it's a problem with the customization. So that's a good way to try to isolate it, whether or not it's a Genero problem or whether it's a customization problem. So if the problem goes away with our default themes that we have, you have to try to use some of these other web developer tools. Firefox has Firebug, Chrome has their own web development tools, Microsoft has a developer environment that has a debugger, so those are all possibilities to try to get in there and figure out exactly at what layer that actually occurs. And again, there was a lab. There's lab 2, and I understand you probably won't be able to actually perform all the steps in that lab if you don't have the Office Store application available, but you might anyway just go ahead and read through the lab because it does have, I think, some kind of interesting ways to use the debugger tools to get to a certain point or to quickly find a problem, and you might just kind of read through it even if you're not actually able to do it. All right. See if I can get out of there. There we go. So that was all the slides for the presentation. And I know there were some things we were going to look at real quick right here in Studio, so let's take a look here. Let's see if I can remember some of them. One of them, I was going to show you the profiler. So we'll just start it out here. Or not the profiler. What was it? The sequence diagrams? We were going to look at I'll just start out there with the dependency diagram and work my way down real quickly. I don't remember exactly which one it was. So here's the dependency diagram that we were talking about earlier. So I'm just going to go ahead and right-click on the entire project here. So it looks fairly small and straightforward. But I can expand a node. Let me expand one of these. There's not a whole lot to expand on the accounts node. Just telling us that the accounts application node has a dependency on the account.4gl file. So not a whole lot going on there. But I can right-click on this entities node and expand that, and that's when things get more exciting. Right? There's a lot more going on with those entities. I can click on any of these links that show up as arrows here, and that puts me in this function calls view that we looked at earlier. Spread that out a bit so you can see it better. And you can actually see a lot of information about the functions that are used. I picked a simple one there. And then you can right-click on any of the functions here or in the diagram structure view, the dependency diagram structure view up here on the right-hand side, and you should see the open sequence diagram option there. So I'm going to click that, and that switches us over to the sequence diagram. This one's fairly straightforward, pretty small. Can't grab that. There we go. So I can see here this is where the user enters the application here in account.4gl at the main. First function call is account form UI open form. And then it returns back to the main. And then right here, of course, there's all kinds of things going on. Got that node that I can open up and show subcalls. And if I click the show subcalls, then I can see all the subcalls from this account form UI open form function. And then I can also see them over here in the sequence diagram structure view as well, so that I can explore that way too. All right, any questions about the dependency diagram or the sequence diagram? What else were we going to look at? Anybody remember? Mark, do you remember?
Macros?
Sorry?
Talk about macros?
Oh, the macros. Thank you. I knew there was something that we were going to look at. I told you I would forget if you didn't remind me. All right. Oh, dear. And, of course, I believe, where is that? All right. Oh, it is in this one. I was trying to remember which project I had that in. I believe it was this one. All right. So let me get out of here. Let's see. All right. So I'm just going to, it's here. So I'm just going to go ahead and start this debug session here. And it may take me a couple of tries because I haven't tried it here for a little while. All right. So here I am in my debug session. If you look in the debug menu, right here is where I recorded the macro. Notice it's grayed out right now because I'm at an interactive dialog statement is why this is all grayed out. But I can record a macro, stop recording when I'm through. So that's how I made this file with this list of debugger commands in it. And then later I can come back in and play the macro again and replay setting breakpoints or setting watch points or whatever it was that I was doing when I was recording the macro. So here I'm going to interrupt because I can't obviously play while I'm sitting at an interactive dialog. All right, so now that brings me back to debugger control. Let me see if it let me now. And I'm going to, first let me show you, I don't have any watch points, right, so there's none there. So I'm going to pop up here now and try to play my macro. Now, of course, the big question is, can I remember where I saved it? All right, here, debugger. And it's just a file, just a text file. There it is, debug macro test. That's what I called it. So it doesn't...
Does it have a particular extension?
You know, I didn't see one. I didn't see an extension on it. But Windows sometimes hides things from me, but I didn't see an extension on it. And if I go right over here to the command view, you can see that it did execute that file. There's watch, and there's the name of the variable that I put the watch point on. Oops, there's a break. Right, so there's a breakpoint command. I'm watching, adding it to watch. And then here's a condition that I'm adding to the watch point. So I created a conditional watch point is what that's saying there. So I still don't see them here, but that's because, once again, I'm sitting here at an interactive dialog statement. And then as soon as I make the application continue, notice that I can see my watch points here. So it replayed them. Right, so now I have a new breakpoint and two new watch points, right? One of them is conditional and one of them is not conditional. Was that okay? Are you comfortable with that, or?
Yes, I am. Is it possible to bring up that file?
Sure. Sure. You bet. 1 second. Let me bring this over. It's trying to run away. There it is.
Oh, perfect.
Yeah, very simple. It's just basically a list of commands.
Which I would probably VI and edit that file.
I don't see why you couldn't. That's
I've done it with the old Informix 4DB files, which is basically the same thing.
Yep, I believe so.
Perfect.
So I think that would be perfectly fine. You're welcome. All right. Let's see. Delane, are you there? All right. I guess he's still busy. I think he was maybe looking up the answer to a question or doing a little test run for us So he must be still busy with that. Oh, is that you?
Yeah. I was mute.
Oh, okay. Were you working on a test for us?
Yeah, I have that. Also, I needed to ask, did you need Laurent to come on for some reason?
Oh, well, it was more or less if somebody wanted a little more information on anything that I'm not an expert at. Anybody want a little more explanation on a topic from Laurent? Everybody good? Okay. Well, I guess that's a no. I guess we're okay then. Unless there's something he would like to talk about. He's more than welcome.
About can you hear me, Lisa?
Oh, no, I didn't. I'm sorry.
About the issue with the includes. Give me just a minute. I'll wrap up a project and I'll Skype it to you so you can pop it open for them.
Oh, okay. Okay. Or I can turn over presentation rights to you if you prefer.
Or maybe it'd be a good time also to have a 5 or 10 minute break.
Okay. That sounds good.
And I think you and I can be done with this.
That sounds great. Okay. Does that sound good to everyone? Do you mind taking like, let's say it's 12:20 Central Time. How about, do you think 10 minutes is good enough, Delane?
I think so.
Okay. Well, let's shoot for at the half hour. Does that sound good to everyone? Come back in 10 minutes? Okay.
Sure.
All right. I'll see you in 10 minutes. Thank you.
For it's perhaps possible that that include works for non-executable code as well. Meaning you can use that include for variable definitions in line. And so there's no way to step into that. So it may be indeterminate on how to handle that in the debugger, since there's two ways the includes can be used. Does that make sense?
Yeah, yes, I understand.
So, you know, one great use of that include would be creating abstract data types or user-defined data types. So, like, you can create a data type called customer, and then you can define a variable in your program, you know, called this customer is defined as customer, and then you can use the ampersand include above that declaration to include your definition of a customer data type.
Cool.
Okay. Thank you, Delane. I appreciate you doing that. All right.
Yeah.
I just remembered one last thing I was going to show you guys before we stop the session for the day, the environment variables. So let me just show you real quickly. It won't take but just a minute where those are located. You can see my entire screen. Can you see me down here at the very bottom of the screen where I'm clicking the, well, I can do it up here in Tools Tools, Configurations. So right here I'm in my desktop configuration, and I'm going to hit Configure again, and I'm in this Genero Host Management screen. And right here there's a debug environment set is what I'm looking at. I'm going to click that, and you can see here this is how you can set environment variables for your studio environment. And here's SQL debug, that's for web services debug, that FGLWS debug, and there's the one for the report writer. So some of these will already come pre-configured in host management here, but of course you can change the values for them if you like. They're defaulting to 9, which is the highest value for the debugger, so the most messages you can get. And any of those environment variables that we went over in that last chapter, you can, not all of them are done this way, but most of them are. You can add them right here by just clicking on the plus symbol. And then you can add your environment variable and the value that you want to set it to right there, so that it shows up here. And then you would apply it and click OK. And then right here in the configuration management screen again, there's the debug environment set that you need to click, to select, and then apply that.
Might be worth noting that if you want to, or if you already have debugging logic programmed into your applications that checks to see if an environment variable is set so that the debugging logic starts logging to a file, this is one way you can do that, set that environment variable.
Okay.
Is to add that debug set when you turn it on, or you can add your own environment set for your own debugging environment variable.
Alrighty, let's see. What was I going to do? I think I'll just execute this, and you can see all that additional stuff because of the environment variables being set. And you can see there's a lot of SQL debug messages there because that SQL debug environment variable was all the way up to 9. So tons of stuff. Pardon?
How big is the filter messages? How big is the buffer? Will it?
I don't know. That's a good question. I think it will show you everything from certainly the current session.
Okay. So you just scroll back.
Okay.
Yeah.
I'm scrolling.
As far as I've ever seen.
Get my mouse under control here. Here we go. So over here, scrolling. Yeah, there's a ton. Okay.
Can you direct that output to a file?
No.
Copy paste, which I Control C.
Okay. So I think that was everything I was planning to show you. If I've forgotten anything, I apologize. All right. Any other questions before I let you loose to go eat today?
Will you give us access to the slideshow so we can?
I have no problem with it. I don't think there's any rules against it, so I'd be glad to let you have it. Sure.
I'm just wondering how would we get it?
You know, the easiest way, what I'm mulling over, the easiest way would probably be for me just to pop it right up there where I did the lab files. Did you see the materials area?
I did, and I looked again today, and it hadn't changed.
No, I haven't added anything to it. So I tell you what, I will post it there in that materials link. And I'm assuming that even though I end the session, that hopefully you'll still be able to access that. So I tell you what, if you're not able to access it for some reason, just send me an email, and I'll just zip it up and email it to you.
And how about the recording?
The recording, I will actually, there's going to be a follow-up email that this Go to Training interface is going to send you after the session today, probably in maybe a couple of hours. It kind of varies. But I will actually put the links to these 2 sessions, the one from yesterday and today, in that email. Does that work?
That's perfect. Thank you.
Okay.
Yes.
Okay.
Thank you.
You're welcome. And let me know, like I said, if you don't have access to the PowerPoint slides. There's a few fixes that I saw as I was presenting them that I want to make before I let you have them, because I don't want there to be errors in there. But let me know if you're not able to access that materials site after the session closes, and I'll email it to you. Okay?
Sounds good.
All right. Well, thank you very much. I sure appreciate everybody's attention the last 2 days and sticking with it there, especially when we were experimenting a little bit. So if you have any questions later, I think you have my email address. If not, it's lchildress@4js.com. So feel free to send me an email, and if I don't know the answer to it, I'll bug Delane or Laurent for the answer. So thank you very much, and I'll get those materials to you as quickly as I can, and I'll have the link in your follow-up email, so you can look for that a little bit later today. All right, have a good lunch.
Thank you.
You're welcome. Thank you. Bye-bye.